Okay, here let's talk about the NOR gate. The NOR gate is also a universal gate. You remember the NOR gate, it's an OR gate followed by an inverter. So the output of that is equal to A or B complemented. It's an OR followed by an inverter. This is the negative AND, which is the NOR gate. Because here, if we put an A, it's inverted here, and a B is inverted here. So what we have here is A bar ANDed with B bar, which is equal to this after applying the De Morgan's theorem. This here is a 3-input NOR gate, the output of which is equal X or Y or Z complemented, which is the same as the invert AND. We have X bar ANDed with Y bar ANDed with Z bar. Okay, we said that the NOR gate is a universal gate. It's a self-sufficient gate. I can use the NOR gate to build all the logic circuits without needing any other type of gates. For example, to implement the inverter, we have this circuit. To implement the AND gate, we can implement it using this circuit. This is an inverter, this is another inverter into a NOR gate. An OR gate can be implemented using this circuit. It's an OR followed by an inverter. Okay, we said that the NOR gate is a universal gate. So there are two procedures to implement the logic functions using NOR gates only. The first procedure is by using De Morgan's theorem. First, we have to have the function that we want to implement put in product of sum, like f6 is equal to this sum ANDed with this sum. This function is the same as this. We added these two complements here. We take this complement inside, so we have this and this. Notice that the AND here is converted into an OR. And this is the outside complement, stays here. Now this term can be implemented using this NOR gate. And this term can be implemented using this NOR gate. And these two terms are OR together, and then we have an inverter at the output. So this is the circuit that implements this function. Notice that the implementation here resulted in two levels of NOR gates. This is the first level here, and the second level is here. Another procedure to implement logic functions using NOR gates is by drawing the AND OR logic for the function. For example, this function, it can be implemented using this circuit. Now, starting from the output side of the circuit, if we add an inverter to the input here of this AND, an inverter here, nothing will change to the circuit. The same thing with the other two inputs. Notice I started with the AND at the output here. Okay, and this circuit is equivalent to this circuit because this is an OR gate. This is an OR gate and this is an OR gate. Notice here that we have an inverter. Okay, now this inverter we can eliminate by applying the E bar here instead of E. If we have this function and we want to implement it using NOR gates, we can do this. This term is implemented with this AND. This term is implemented with this AND. And this is the OR between these two. This is the OR gate. Now this term here is an OR gate. And all these are ANDed together to give me F. This is AND OR logic. Now I start from the output side of the circuit, the first AND. I add inverters at the input of the AND gate, so we have to have an inverter here and the same here. We go to this AND, we change the inputs by adding inverters, And here we do the same thing. Okay, this will result in this. This is an OR gate, and these are NOR gates. Notice that here A, here it's A bar by taking out this inverter. And this becomes B, and this is A again, and this is B bar down here.